So the first thing we want to quickly look at this morning is this investigation to explore the graph of a binomial distribution and how it varies when n and p change. If you notice, the major parameters, if I may use that, are the number of trials and the probability of success. Those are the two main things. You can argue that, okay, what about Q, which is the number of failure? But of course, that's an extension of P by the virtue of the fact that we know the relationship between P and Q. So we don't need to worry about, we don't need to mention that. So just N and P. So when N changes, when P changes, how does the graph of the distribution, what happens to it? So we're going to look at that together. So again, in this demonstration, you will explore, blah, blah, blah. So we're going to use the slider, of course. Now, the first question says, set n to be 25 and p to be 0.1. The question is, what is the mode of x? Yes, together. 2. The next question is, describe the shape of distribution.
Positively skewed.
It's positively scaled. Okay, let's move to the next one. Let's change the value of p and describe the shape of distribution. So p is here. Watch. Comments. Comments.
That distribution.
Yes, try.
Of
The shape of distribution is the comment.
Changes from positively skewed to negatively skewed.
Positive to negative, it has a point there. So here you have positive skew, here you have negative skew. Yes. What else? When p is 0.5, it is symmetric. Right? When p is less than 0.5, it is positively scaled. And as it moves more than 0.5, you have a negatively scaled distribution. That's the observation they want us to notice. Okay? I've probably sent this bar and sent a screenshot to you. Or maybe I can put a screenshot in some printed paper and you just take it. Or you just draw yourself. Which one do you prefer? You just to take a screenshot of that, whatever. It shouldn't take me any stress. I'll probably give you a Monday. You can just take it in your notes. Right? The outcome of this demonstration. Now, we want to reset P to that, and this time around, we want to change N, the slide of N. So let's take this to be 0.1. Now let's start, so N start from 1, and it goes, and it goes, and it goes, and it goes. Observation. Again, from here, yes, that's observation. As I increase n, what do you notice about the shape of distribution? Correct? Becoming more symmetrical when the sample becomes large. Okay, it becomes more symmetrical, or when you have not more trials, because this time around our n is trial, not number of sample. Okay, as you do more trials, the distribution becomes more symmetrical. That's the point here. Let's see what happens if we can get the same thing no matter the value of p, except when p is equal to 1, of course. Okay, no matter the value of p, is it the same? Remember, for p greater than 5, distribution should be negatively skewed, isn't it? So that's why you have this at the beginning. But again, as n becomes more, number of trials becomes more, the distribution becomes symmetrical. That's the whole thing they want us to observe here. Okay, it might come in handy when you are trying to maybe write some comments later in future. Okay, all right, that's one thing I want us to do today. Again, I will write a summary of this. Sorry, I've been so busy with stuff. I'll tell you some of the reasons later. I'll write a summary of this and tell you and give to you on Monday. Then you can stick it somewhere. I will take a screenshot. I will have said, oh, form a note, but I want you to go with the trend of the pictures as well. So I need to take my time to do that. Now, in exams, while you have questions where you use your combination and stuff, you can actually use your calculator as well. So we're going to practice the use of calculator. That's the next one. After that, I will go into the mean of standard and then standard deviation of the probability distribution. The proof is not required, but as a class, we will see how they can be done. And that might help us when you are trying to write a mathematical proof, even in some other subject. Just the thinking process. That's the reason. The proof is not required. What is required is already in our formula booklet. NP, then NP minus NP squared, which is factorized in this form. So we might end up getting the expanded form. Okay, we're going to do that. Then we have standardized number variable. We haven't done that. Okay, that's for number distribution. So that's in the next topic. So this will be the end of this. If there is need for us to review something on Monday, we will do that. I think we will probably practice the first 30 minutes again, then we'll go to continuous random variable. Okay? Since we are now having the weekend date as our Zoom date. All right. So this is the calculator instruction which I will be sending to you. If I have not, I think it's already on the drive, so you can look at it, or I just send the screenshot again. Now, let's go to the question that led to this instruction. Okay, let's just try this one first. If you want to find the probability that x is equal to 2, if you want to find the probability that x is equal to 2 for a binomial probability random variable, for a binomial random variable, what does this term mean? Number of trials, and what does this mean? Probability of success. A binomial experiment with n trials and probability of success of that, how do I say, of the event described by the random variable is 0.3. Understand? These are the calculations you have done using your permutation and combination, isn't it? How is it done with the calculator? So let's go, everybody. Okay, you have stolen mine, that's fine.
I'll just.
No, make use of it, don't worry about it. I was just kidding. I can actually, I have the emulator, it works now, the calculator stuff. Is it working? Oh, yours is different. Oh, is it the same? Okay. So let me know if you have gotten 0.233.
Yeah.
You got that? Okay. Again, you might want to get, probability of x less than or equal to. Like the case of less than or equal to 18, you guys were arguing a while ago. Okay? In the case of that, of course, you can actually use the second instruction. So you can see the difference. BPD, BCD, binomial probability distribution. I want to believe this is like cumulative. Because remember, it's everything from a place to a place. Okay? Can you see the difference?
Yeah.
This is C. So F1, F2, the difference. This, we are just looking for the distribution, that exact distribution, exact probability. But here, we are talking about from one point to another, less than or equal to 5. Okay? Clarissa, everything all right? You want to come forward? Come forward. Oh, I can enlarge it, then I get rid of that.
No, I don't. Okay, different model. Different model. Okay, so just 5. Yeah, just 5. Because it's
You want more lower and upper, right?
yeah.
You don't have lower?
Which is
Cool
cool.
illuminated
It's
screen.
so cool.
You have to
Would you
use
like
one
to try?
minus.
Oh, so your but that calculator should have it, right, Mr. Chang?
Hmm? Yeah,
Yes.
it works, yes.
Oh,
It works.
too bad.
We are lower grade.
Yeah. Thank you.
This is like
The calculator is not
No,
full.
one minus for
Mine is cool.
It's so
This
cool.
is like the Toyota. This is like the Porsche.
Yeah.
I mean, it's the same.
This is the BMW.
Okay, so in that case, you have to do 1 minus. But even the 1 minus, you have to be able to add, if you have like 10 trials, if you have like 7 trials, it has to be 1 minus the other 2 and added together. So that means you have to calculate the first BPD twice and do 1 minus that, basically. Guys, this is what I'm saying. If you are not able to do the BCD in your calculator because of the level, so I'm not saying because your calculator is hard.
I don't have that problem.
So
Yeah,
if I do
I will in the exam.
the binomial probability distribution of the random variable x with that number of trials and the probability p twice. So if you are dealing with 7, for example, probability that x is less than or equal to 5, and the number of trials is 7. So this will be 1 minus probability that x is greater than 5. So which is 1 minus probability of x is equal to 6 plus minus again probability of, or maybe add everything like this, x is equal to 7, isn't it? So you might want to do this twice if your calculator can't do the BCD. Okay, you do that twice. Then, so when you are writing, there is some instruction here. So I need everybody to adhere to that. When you are writing, here, you see? What is this? It is unacceptable to write the calculator function. No, yes. This is where you must tell us what this is about. If you are having a word problem and you want to calculate something, at the beginning, I need you to put this. Okay? After you identify your random, let's listen to that instruction. After you identify your random variable number of trials, this is telling you it has checked all the boxes of being a binomial probability distribution, and you have identified the number of trials and the probability of success P associated with that random variable. So this is like saying, oh, therefore this is a binomial distribution, or therefore my random variable is a binomial random variable. That's what this line means. In that case, you can go ahead and either you use your combination, whatever, or you go ahead and use your calculator, depending on what it requires. So anyways, let's look at one of this, then we do some experiments on the calculator using 1 or 2 questions in the exercise, and we move to the last thing, maybe in the last 15 minutes. Come on, load on time. So slow. Hopefully we don't have an issue today. What is the problem, Mr. Chen? What's the problem? Is it about my calculator being
In
cooler
the
than
previous
yours?
example, we used the binomial expansion to help us calculate probabilities for a binomial random variable. that case, the number of trials was relatively small, so we could write the binomial expansion out in full. This is not always practical, so for a large number of trials, we use technology to help us calculate probabilities. In this example, we are told that 72% of union members are in favor of a certain change to their conditions of employment. If they are not in favor of the change, they are against it. So, asking a member of the union their preference is a trial of an experiment with two outcomes, success and failure. When we take a random sample of 5 members, we have 5 trials. We let X be the number of members in the sample in favor of the change. Before we decide that the experiment is binomial, we also need to consider whether the trials are independent, and therefore the probability of success will be the same for each trial. Since we are sampling 5 members of the union at the same time, we cannot select the same member more than once. This means that the trials are actually dependent. For example, if the first member sampled was in favor of the change, then the probability that the next person selected will be in favor will be slightly less. However, if the population is sufficiently large, the probability of selecting a member in favor of the changes will be approximately the same for each trial. We therefore assume we have a binomial experiment. 72% of all union members are in favor of the change, so the probability of success is 0.72. In part A, we want the probability that exactly 3 members in the sample are in favor of the change. We can write out the probability using the probability function. Remember that the probability of failure is 1 minus the probability of success. The result is approximately 0.293. Alternatively, we can use the inbuilt binomial probability distribution function on many calculators. If you need help with this process, follow the link for your calculator model. In part B, we want the probability that at least 3 members in the sample are in favor of the change. This is the probability that X is greater than or equal to 3. We could write out expressions for all the possible cases and evaluate them, but this would take a long time. Instead, in part B, we want the probability that at least 3 members in the sample are in favor of the change. This is the probability that X is greater than or equal to 3. We could write out expressions for all the possible cases and evaluate them, but this would take a long time. Instead, we use the inbuilt binomial cumulative distribution on our calculator. You need to be aware that some calculators will only calculate the probability of a binomial random variable being less than or equal to a certain value. For these calculators, we find the probability of the complement, in other words, that X is less than 3, and subtract it from 1. So, the probability is approximately 0.862.
Okay. Let's try 1 or 2 from the, I'll send you screenshots. Let's try 1 or 2 from here using the calculator. So let's discuss it together and try to use calculator. So the first one, 5% of electric light bulbs are defective at manufacture. 6 bulbs are randomly tested, with each one being replaced before the next one is chosen. So they are independent. So that tells you independent trials, isn't it? Determine the probability that 2 are defective. So we have a binomial distribution with what? What? 6. 6, comma. So the first one, probability that the random variable. So the random variable, it represents what in this case?
Number of defective.
Number of defective. You can look at the question. you want to find the probability that 2 are defective. That means the probability that x is equal to 2. So x must have been the number of defective balls. Okay? So probability that x is equal to 2. So use your calculator function. You don't need the cumulative distribution. You need just the probability distribution, the BPD. Okay? Use that to work this out. What do you get in the calculator? 0.0030. Like this? 3-1. Okay.
Rounding.
Like that?
Yes.
So this is approximately that. The probability that at least one is defective. Guys, at least one is defective. X greater than or equal to 1. So this is the same as we can do the complement, isn't it? 1 minus probability that x is less than 1, right? So which is more or less 1 minus probability that none is defective. Is that it? So do this on your calculator and do 1 minus later. So when you do that in your calculator, just say 1 minus answer, isn't it? So, or if you have the type that it's using, you can use the BCD. Just go to F2. I mean, if your calculator is cool, like if it's calculator.
This would be a really nice grad gift.
If you want to use it for the exam, I'll let you use it. I have HP Prime. If you want to use the HP Prime, I can give you. But I don't know if you know how to use that.
We need to do rock paper scissors.
Yeah, we need to fight over this.
We need to fight.
No. You don't have to. You can talk to the Form 5. I can actually talk to the Form 5 and get their calculator.
They have these as well?
Yeah, we recommend this year. It's an upgrade.
Oh my god.
So we recommended this year.
That's so
It's a new upgrade.
They don't upgrade us, but they upgrade the
No, it's not the school. The Casio, the IB, everything upgraded like calculator. These are calculator allowed now, henceforth.
I don't
so we
like
looked at
IB.
it.
Let's take
So,
it. Let's take it.
guys, so we looked at it as a department, and we thought, okay, the upgraded version is better. It was when Mr. Kim was still here. So we'll send the list of books out. But there was no point sending your list of book with a new calculator when you already have one.
Let's think of it this way. Maybe the IB exam paper knows that we have a worse calculator. Don't put this in the exam question.
So I can talk to the Form 5 and get some of this. If you want, tell me on time so I can book their calculators. Okay?
We can swap their nice calculators for
No, you just
for
need it
like
for the
ancient
exam.
ones.
After that, you don't have business with it, isn't it?
Can we
No,
use
I'm
can
going
we
to
use
university with Alex's
together?
calculator.
So anyways, let's quickly look. So some of these, please use the calculator more often on your own. When you calculate and you show your end combination, whatever, you can actually use calculator to quickly check if your result is the same. If it is not the same, go back and see. Maybe you put the combination wrong somewhere. It's a nice tool to double check and be error free at the end of your exam. That's the way I look at it. Okay. Okay, let's quickly come here. I hope we will not have any issue with this. Okay, let's start from here first. The mean of a probability distribution is the expectation. Okay? So for the binomial probability distribution, the mean is expectation of x as expected. But what is that? So let's x be a binomial random variable with n trials and probability of success p. Okay? Then mean mu is equal to Mr. King, I'll find you when I'm done. I may not be able to get to it at this point now. That's fine. This expectation of x, which is equal to probability of x times p of x. But rather than p of okay, yeah, we leave it as p of x is fine. So xi something like that, I is equal to 1 to n. Okay? Now we know what our probability p of x is that combination stuff, isn't it? So this is simply the summation of x. Instead of xi, just say x. We have n combination x, is that not? P raised to power x, q raised to power x. Or do you prefer 1 minus p? Do you prefer 1 minus p to q? 1 minus p. Okay. N minus x, sorry. Okay? Remember, your x is equal to 0 to n. I think I'm trying to.
Maybe change the
I'm trying to. You know, if you're having a probability here, usually is you alternate. Your x is from 0, 1, 2, 3 up to n, isn't it? I'm trying to make sure I do not confuse you with this. So let's just leave it as I think I've just write it is better. X times probability. Let's leave it as this is better. We are not speaking in general anymore. Okay, we are not talking about just any probability distribution. This is the binomial probability distribution. So I restrict the notation to that. So this is what we want to simplify and ensure that we get NP. So the first thing is this. When x is equal to 0, nothing happens. X is equal to 0, so this is gone. So basically, this is more or less when x is equal to 1, x n combination x p to power x 1 minus p to power n minus x. Do you agree?
Yeah.
Because when x is equal to 0, everything is equal to 0. So 0 times probability is equal to 0. So basically, because 0 times probability of 0 is equal to 0. That's what has happened here. So it's more or less starting from 1. Okay? Now, let's open what this means. This is summation. X is equal to 1 to n. X times, this is n factorial, n minus x factorial, x factorial. Agree? And this is p to power x. This is 1 minus p to power n minus x. Okay? I want to eliminate this x, so I can do, because of space, x is equal to 1, x n minus x factorial, x times x minus 1 factorial, right? Then this is x n factorial. This is p to power x 1 minus that. Agreed? So my x can be removed. So I am now left with, okay, n minus x factorial, x minus 1 factorial, yes? This is what? N factorial. And, okay, one thing I could also do, I'm trying to get NP, remember. One thing I could also do is change this immediately, expand my other one, n minus 1 factorial, right? So in that case, my n can be taken out, x is gone, I have here n minus 1 factorial. I'm going to do some variable transformation now. P to power x is kind of difficult when I write 1 minus p, I'm used to q. Okay. So, watch what I'm going to do here. Let x minus 1 be a new variable y. If x minus 1 is a new variable y, then x itself is y plus 1. Do you agree? The reason for that is this. When x is equal to 1, what happens here? What? When x is equal to 1, it doesn't make sense when you say just say 0. Y is equal to 0. So this automatically becomes y is equal to 0 to n. No, not n anymore. Is it n? Yes, it's still n. Nothing happens to our n. Or is it? x from 1 to n. Yeah, so y from 0, because there's a change, right? Y from 0 to n minus 1. Y from 0 to n minus 1. So there are n of them. So this will be 0 to n minus 1. So there are n of this as well. Do you agree?